Hello, my name is Borys and I am Senior React Developer at Luxoft. In this talk, I will address web application security from a front-end perspective. At this point, I have conducted more than 100 technical interviews, and I think this area of knowledge within web application development is underestimated by developers. I fundamentally believe that every front-end developer should have at least some knowledge about security and some practical expertise in this field. To remediate that, I will discuss OWASP, cyber attacks, and ways to protect against them. I will also give you practical recommendations that you can implement in your projects. I would like to start with the review of the OWASP Top 10. OWASP is a non-profit organization that works to improve the security of software. It stands for the Open Web Application Security Project. Every 4 years, it produces the Top 10 list. This is a standard document for developers and web application security professionals. It represents a broad consensus about the most critical security risks to web applications. Companies should adopt this document and start the process of ensuring their web application minimizes these risks. Using the OWASP Top 10 is perhaps the most effective first step towards changing the software development culture within your organization into one that produces more secure code. In this figure, you can see the changes between 2017 and 2021. There are 3 new categories, 4 categories with naming and scoping changes, and some consolidation in top 10 for 2021. We will consider only few entries that are related to front-end, and we will also add a couple of points that are not included in the top 10, but they also related to security of the front-end applications. So they collect the most comprehensive dataset related to identified application vulnerabilities to date to enable analysis for the top 10 and other future research as well. This data should come from a variety of sources: security vendors, consultancies, bug bounties, along with company or organization contributions. Data will be normalized to allow for level comparison between human assisted tooling and tooling assisted human. The first threats I want to consider are injection attacks. There are many types of these attacks, but the main ones are SQL injection, cross-site scripting, code injection, and common injection. Let's focus on 2 types, SQL injections and cross-site scripting. SQL injection is the placement of the malicious code in SQL statement through injection on the page. This code injection technique can destroy your database or remove some information. Of course, protection against this attack should be located on the server side. Nothing special should be done in terms of front-end. It's enough to have a form validation. In the picture, you can see an example of how it works. There is a form with fields in which the data from the form becomes part of the SQL query. If you don't validate it, don't escape the data, the SQL query can be changed as an attacker wants. Why is it important to know? In some situation, an attacker can escalate an SQL injection attack to compromise the underlying server or other backend infrastructure, or perform a denial of service attack. Let's move on to a more interesting injection attack for frontenders, cross-site scripting. Cross-site scripting has been a part of the injection attack section of the OWASP Top 10 list since 2021. XSS vulnerabilities allows an attacker to steal the session credentials and hijack an active user session, defeat the appearance of their website, tamper the victim's intranet using an XSS proxy. There are three different types of XSS: stored XSS, reflected XSS, and DOM-based XSS. First, about the stored XSS. Stored XSS vulnerabilities are the most dangerous. They generally occur then when a user input is stored on the target server, such as a database, in the message forms, visitor logs, command field, etc. And then a victim is able to retrieve the stored data from the web application without the data being made safe to render in the browser. With the advent of HTML5 and other browser technologies, we can envision the attack payload being permanently stored in the victim's browser, such as an HTML database, and never being sent to the server at all. The second one is reflected XSS. Reflected XSS vulnerabilities are more common. Any part of an HTTP request can be used for an XSS attack. Cookies, headers, query string parameters, form fields, and hidden fields. Reflected XSS occurs when user input is immediately returned by web application in an error message, search result, or any other response. That includes some or all of the input provided by the user as part of the request, without the data being made safe to render in the browser, and without permanently storing the user-provided data. In some cases, the user-provided data may never even leave the browser. And the third one is DOM-based XSS. It may appear in AJAX and Web2 application. This attack happens inside the browser and never involves the server. DOM-based XSS is a form of XSS where entire tainted data flow from source to sink takes place in the browser. That means the source of the data isn't in the DOM. The seek is also in the DOM, and the data flow never leaves the browser. For example, the source where malicious data is read could be the URL of the page, for example, document.location.href, or it could be an element of the HTML. And the sink is a sensitive method called this causes the execution of the malicious data. For example, document.write. DOM XSS versus reflected XSS. What's the difference? While DOM-based XSS shares a few similarities with traditional reflected XSS, there are a few fundamental differences in technique and implementation. Reflected XSS aims to embed client-side data in the server-side code in HTML documents, while in DOM-based XSS, the malicious payloads are referenced and executed on the client-side environment. Reflected XSS can only target dynamic web pages, while DOM-based XSS targets static and dynamic web pages. DOM-based attacks largely remain undetected if the adversary avoids server-side identification techniques, while traditional reflected XSS attacks are easily detected using intrusion detection system and logs. There are two primary defenses against XSS: output escaping and input validation. First, about output escaping. You have to sanitize the content received from the server. Malicious script can be in HTML, CSS, and JavaScript code. Second, regarding the input validation. You have to apply it both on the server side and in the front-end side. To protect against DOM-based XSS, avoid updating the DOM with user-supplied data via methods such as document.url, document.location, document.refer without any validating the data. We have to use safe JavaScript APIs. However, developers frequently don't know which JavaScript APIs are safe or not, never mind which methods in their favorite JavaScript library are safe. OWASP's guidance on how to do this properly is presented in the DOM-based XSS preventing cheat sheet. Next, I want to show what can be used to sanitize data from JS scripts to avoid XSS attacks. Here is the sanitize URL library, and it's used in places where you pass the URL that come to you, for example, from the server. Next is another library that is used for sanitizing HTML. It is called Temporify, and it's also quite popular, and it's regularly updated. Here's an example of what it does, and if you're familiar with React, you may know what there is a dangerous set-inner HTML attribute in React, what allows you to integrate some HTML code, what may come from the server. In this case, you also need to sanitize this code, and you can use this library. All injection attacks have common features, so let's consider when a web application can be vulnerable to injection attacks. There are 4 key points. The data provided by the user is not validated, filtered, or cleaned by the application. Dynamic queries or unparameterized calls without content-sensitive escaping are used directly in the interpreter. Hostile data is used in ORM search parameters to extract additional sensitive records. Hostile data is used directly or merged. The SQL or command contains structures and malicious data in dynamic queries, commands, or stored procedures. There is also an attack called CSRF. Let's look at what it is and compare it with XSS. Cross-site scripting, or XSS, allows an attacker to execute arbitrary JavaScript in the victim's browser. Cross-site request forgery, or CSRF, allows an attacker to induce the victim to perform actions that they didn't intend to. The consequences of XSS vulnerabilities are usually more serious than CSRF vulnerabilities. CSRF can be characterized as one-way vulnerability, in which an attacker can induce a victim to send an HTTP request, but cannot receive responses to that request. Conversely, XSS is two-way, in the sense that an injected script can issue arbitrary requests, read responses, and transmit data to an external domain of the attacker's choice. Some XSS attacks can indeed be prevented by the effective use of CSRF tokens. Where can we store session data, for example, JWT? It can be stored in cookies in local storage and in cookies with the HTTP-only flag. The worst scenario is to store JWT in cookies without the HTTP-only flag, as cookies are vulnerable to CSRF and XSS attacks. They have a limit on the amount of data and the number of cookies per domain. For example, to protect against CSRF attack, you can set the same site parameter, but in this case, cross-domain requests will stop working. Storing GVT in local storage is a normal option, but you need to take care to protect the web application from XSS attacks, as local storage is vulnerable. But since the browser doesn't automatically send data from local storage to the server, storing data in local storage protects against CSRF attacks. And the last option is to use cookies with the HTTP-only flag, as the front end doesn't have access to cookies. This flag. This method protects against XSS and CSRF attacks. Next, let's take a look at clickjacking, what it is and how to prevent this attack. Clickjacking is a malicious method that forces the user to click something different from what they perceive. Let's look at a simple example with a forced like. For example, you open a site and of course click something in the user interface. However, the site owner can't impose some transparent frame in which there will be some social network functionality covering every button. So when you click, you will click on what was in the frame. If you were on the site that was linked in the frame, then you will perform some actions such as liking a post or page without ever knowing it. How do you protect yourself? There are two ways: content security policy and X-frame options, which can be prohibited to use of your site in frames or restrict where this can be done. We are almost at the end, but I would like to give you some more recommendations. Content security policy. Using this header, the browser can limit the list of resources allowed to communicate with your front-end application. Each type of resource is configured separately: images, JavaScripts, CSS files, fonts, XHR requests, etc. And the wrapped URI parameter sends all policy violations to your server for login. The next header I'd like to discuss is feature policy. It is good security practice to restrict access to anything what is not necessary for the proper use of your web applications. We can apply something similar with a content security policy. For example, to limit the number of domains web application is allowed to connect to, but it can also be applied to browser features. We can tell the browser to deny access to certain features and APIs what are not needed by our application using the feature policy header. We set a string of rules in feature policy separated by semicolon, where each application rule is a feature name followed by the policy name. There is also APIs for viewing all feature list. You can also see all of them as well as which are available. The next header is the referrer policy. Do not allow the referrer value to leak. When you click a link that leads from your site, the target site will receive the URL of the last location on your site in the referrer header. This URL may contain sensitive and semi-sensitive data, such as session tokens and user IDs, that should never be disclosed. Next thing I'd like to mention is sub-resource integrity. For all third-party scripts you use, don't forget to enable the integrity attribute. Browsers have a function that checks the integrity of sub-resources. The browser can check the cryptographic hash of the files you are downloading and make sure it hasn't been tampered with. Next, I'd like to highlight the topic of performing a vulnerability audit against the installed packages. There is always a risk that the packages you use may contain some kind of vulnerability. You need to use reliable third-party packages and pay attention to the frequency of updates. There is a built-in command, audit. It checks for known security issues with the installed packages and asks you to update them. The output is a list of known issues. You can check groups of dependencies like dependencies and dev dependencies and peer dependencies. Moreover, you can add the command as a separate CI/CD step. There are also paid tools for performing a vulnerability audit against the installed packages. There are, for example, Dependabot and Sync. They could be built into some internet hosting services for software development and version control. For example, GitHub uses Dependabot by default, and it is for free. What about checking a source code you wrote for vulnerabilities automatically? One more interesting and useful tool, SonarQube. I have experience of using it on my latest project. SonarQube empowers all developers to write cleaner and safer code. There are thousands of automated static code analysis rules protecting your app on multiple fronts and guiding your team. It catches tricky bugs to prevent undefined behavior from impacting end users, asks to fix vulnerabilities that compromise your app, and asks you to make sure your code base is clean and maintainable to increase developer velocity. It can be integrated here into GitLab, GitHub, Bitbucket, and Azure. That's it I wanted to talk about. Thank you for your attention. Bye-bye.